Coagulation. What is coagulation? A method used to alter the colloids so that they will be able to approach and adhere to each other to form larger flock particles. To turn the small particles of color, turbidity, and bacteria into larger flocks, either as precipitates or suspended particles. Why the colloids are suspended in solution and can't be removed by sedimentation or filtration. The particles in the colloid range are too small to settle in a reasonable time period, and too small to be trapped in the pores of a filter. For colloids to remain stable, they must remain small, and most colloids are stable because they possess a negative charge that repels other colloidal particles before they collide with one another. Colloid destabilization. Colloids are stable because of their surface charge. In order to destabilize the particles, we must neutralize this charge. Such neutralization can take place by the addition of an ion of opposite charge to the colloid. Since most colloids found in water are negatively charged, the addition of sodium ions should reduce the charge. Figure 6.6 shows the effect of salt on electric potential. The plot shows surface charge as a function of distance from the colloid for no salt addition, low salt addition, and high salt addition. As we would have predicted, the higher the concentration of sodium we add, the lower the charge, and therefore the lower the repelling forces around the colloid. Figure 6.7 shows effect of valence on electric potential. If, instead of adding a monovalent ion such as sodium, we add a divalent or trivalent ion, the charge is reduced even faster, as shown in figure 6.7. In fact, it was found by that 1 mole of a trivalent ion can reduce the charge as much as 30 to 50 moles of a divalent ion and as much as 1,500 to 2,500 moles of monovalent ion. Coagulant, substance or chemical added to the water for it to undergo coagulation. Key components of coagulant. Trivalent action. As indicated in the last section, the colloids most commonly found in natural waters are negatively charged. Hence, a cation is required to neutralize the charge. A trivalent cation is the most effective cation. Non-toxic. This requirement is obvious for the production of the safe water. Insoluble in the neutral pH range. The coagulant that is added must precipitate out of solution so that high concentrations of the ion are not left in the water. Such precipitation greatly assists the colloid removal process. Most commonly used coagulants. Aluminum sulfate. When alum added to the water, this reaction occurs. The above reaction shifts the carbonate equilibrium and decreases the pH. When sufficient alkalinity is not present to neutralize the sulfuric acid production, the pH may be greatly reduced. If the second reaction occurs, lime or sodium carbonate may be added to neutralize the acid. When aluminum is added to the water, it immediately dissociates, forming complex products that coagulates. It produces a very large precipitates that catches the colloids as it falls to the water. The precipitates are called flock. Flock formation is one of the important properties of a coagulant for efficient colloid removal. The coagulation process by alum is done by absorption and charge neutralization and swift flocculation. Ferrous sulfate. Oxygen is required for oxidizing the ferrous ion to ferric, since ferrous hydroxide is soluble. The pH must be raised to approximately 9.5 so that the ferric ions are precipitated as ferric hydroxide. Minimum dose of 50 mg per liter. Ferric sulfate. Dense, rapid settling flux are produced and the optimum pH range of ferric sulfate is from 4 to 12. Minimum dose of 25 mg per liter. Ferric chloride. Dense, rapidly settling flux is produced when ferric chloride is used as the primary coagulant. Ferric chloride reacts with the natural alkalinity. If the natural alkalinity is insufficient for the coagulation process, lime or sodium hydroxide may be added to increase the alkalinity, as shown in the following equations. Coagulant aids, pH adjusters, comprises acids and alkali, used to adjust the pH of water in the optimum level during coagulation. Acid that is commonly used to lower the pH is sulfuric acid, while the base commonly used to raise the pH are either lime or soda ash. Activated silica produces stable solution by having negative surface ions binding to the aluminum or iron flux, leading to larger flux formation and denser particle that easily settles. The addition of activated silica is especially useful for treating highly colored, low turbidity waters because it adds weight to the flux. Clay acts just like activated silica, adds weight to the flux but with slightly negative ions. Useful for colored, low turbidity water, but clay is not commonly used. Polymers are long-chain carbon compounds of high molecular weight that have many active sites. Can be anionic, cationic, or non-ionic. The active sites adhere to flux, joining them together and producing a larger, tougher flux that settles better. This process is called interparticle bridging.